Let's quickly understand the problem. And hey, if you are here just for the code walkthrough, feel free to skip ahead, but for intuition, approach, and why this works, stick around. So today we are dealing with a classic problem, maximum subarray. Here's the question. We are given an integer array nums. We need to find the contiguous sum that is containing at least one number which has the largest sum and return that sum. Let's take this array for an example. The maximum subarray is 4, -1, 2 and 1 with a sum of 6. So let's go on to the intuition. When I first saw this, my instinct was, could I keep track of current subarray sum as I go? And then it hit me that if current running sum ever drops below 0, it won't help any future subarray. So we should just start fresh from the next element. This is the core idea behind Kadane's algorithm, a super handy greedy technique you'll find in many DSA problems. So the strategy that we'll be using is, we'll loop through the array, keeping track of current sum, the sum of the current subarray, and maximum sum, the maximum subarray sum we have seen so far. If current sum drops below 0, reset it to 0 because a negative sum won't contribute positively to future values. Alright, before we walk through the code, quick reminder, pause the video and try coding this yourself. Then come back and compare your approach with this one. Let's walk through this step by step. We start with a max sum and a current sum. Max sum holds the best subarray sum we have seen so far. We initialize it with the first number in the array. And current sum tracks the sum of the current subarray we are building. Then we loop through each number in the array. We keep adding the current number to our current sum. After each addition, we check if our current sum is better than the best sum we have seen so far and update max sum. If our current sum ever drops below 0, it is not going to help any future subarray, so we reset it to 0 and start fresh from the current number. We return the maximum subarray sum we found. So the time complexity here becomes O of n because we only loop through the array once, and space complexity O of 1 since we are using a constant amount of extra variables. So this is simple, clean and super efficient. This is why Kadane's algorithm is a favorite in interviews. If you want to give a try yourself, you can check out maximum sum circular subarray, maximum sum rectangle in a 2D matrix, and a few variations like maximum product subarray where the logic is tweaked but the principle is similar. So like I said, understand this idea now because you will spot it in many disguised form later. Follow Code in 60 on Instagram and on YouTube for more quick coding breakdowns, and drop your next problem in the comment.